Welcome to today's lesson on representing linear non-proportional situations with graphs and equations in the form of y equals mx plus b. So we have two TEKs that we're working on today. It's 8.5b and 8.4c. And then our essential question is, what is the difference between the graphs of y equals kx and y equals mx plus b? So the first thing that I'm going to do is distinguish that y is equal to kx is for proportional relationships. And if we remember proportional relationships, I'm going to go ahead and draw a little mini graph right here. Always go through the origin. So the origin is that 0, 0. So I'm going to go ahead and highlight that right here. And then y equals mx plus b, as we know, is for non-proportional. And if I were to draw a graph for that, it might look something like this. So in this case, it does not go through the origin. It goes through a number. So let's say that number, just for clarity's sake, is 3. So I can either write this point as 0, 3, or I can say that b, or the y-intercept, is 3. And as you can see, we use b to represent the y-intercept. M and k are essentially the same thing. K is known as the constant of proportionality. M is known as the slope, but they're both rates of change. So if we remember k, the formula for k is y over x, and the formula for m is y2 minus y1 over x2 minus x1. For both of them, it's asking for the change of y divided by the change of x, right? Because we have y's on top, x is on bottom. Okay, so our vocabulary words for today, we have linear equation. So that's an equation between two variables that is a straight line when graphed. So both the proportional and non-proportional graphs that I showed right here are linear equations. Slope-intercept form is the equation of a straight line in the form of y equals mx plus b, where m is the slope and b is the y-intercept. So I just went over that. Y-intercept, again, is the point where a line intersects or crosses through the y-axis. And lastly, rate of change, it's a rate that describes how one quantity changes in relation to another quantity. So rate of change is another word for that k, another word for that m, another word for constant of proportionality, unit rate, constant of variation. Okay, so we have our first activity. It says Jack and Jill are walking back home from the bus stop, which is 30 yards from their house. They walk at the same rate, which is 4 yards every 3 seconds. And we have to consider the two graphs shown. Number 1 is saying analyze the graph of Jack and Jill walking home from the bus stop. And 1a is saying, does this situation represent a proportional or a non-proportional relationship? So this situation is specifically talking about walking home from the bus stop. So I know that I'm looking at this right graph, walking home from the bus stop. I'm going to zoom in a little bit. So I can see that it does not go through the origin. It goes through 30, right? So our y-intercept is 30. That means that this is a non-proportional relationship. And to answer 1b, it says, is the slope of the line positive or negative? So if we look at the line, we can see that going from left to right, it goes down, right? So that's how we know that this is a negative slope. Two is saying to compare and contrast the rate of change or slope of each line. So again, rate of change is the same thing as slope. Okay, so in the graph of walking to the bus stop, they give us an equation, y is equal to 4 over 3x. And we can see that our slope is going to be that 4 over 3. So we have walking to the bus stop, the slope is positive 4 over 3. And now we have to decide for walking home from the bus stop. So there's multiple ways to do this. We can do that change of y over change of x. And over here, I have to choose another point because remember, for non-proportional relationships, we need at least 2 points, right? For proportional relationships, k is equal to y over x, we just need 1 point, 1 coordinate. But for non-proportional, that's why we have x1, y1, x2, y2. We need 2 points. Okay, so from here, I'm going to choose this point right here. And so if we look on the x-axis and the y-axis, we have to figure out what is the unit counting by, right? What is the scale of x and what is the scale of y? So if we see that every 2 boxes is 5, every one box has to be half of that. So 5 divided by 2 is 2.5. So that means that the scale for X is counting by 2.5s. And then looking at Y, again, every 2 boxes is 2.5. So, or every 2 boxes is 5. So that means that every box is 2.5. Because the scale is the same on both sides, I can figure out my rise over run by just counting the number of boxes. Because that'll actually help me simplify and get my simplest form answer. So instead of doing 30 minus 20, which is 10, I can just count the number of boxes, which is 4. And because we went down, it's going to be negative 4. Then for our run, which is the direction that we're either going left or right, in this case, we're going to the right, we went over 3 boxes. So instead of doing 7.5 minus, well, I guess 7.5 minus 0, which is just 7.5, we have just the 3. So now we figured out our slope for this graph on the right. So it's going to be negative 4 over 3. If I wanted to, I can turn the 4 over 3 into a decimal. So for both of them, it would be equal to 1.3 with the 3 repeating, except obviously for walking home from the bus stop, it would be negative 1.3 with the 3 repeating. Okay, so question number 3 is asking, write an equation to represent Jack and Jill's walk home from the bus stop. Let y represent the distance from home and x represent the time spent walking. Okay, so we already have our slope. That is the negative 4 over 3. So we know that this is a proportional relationship. So that's why the form of the equation is going to be y is equal to mx plus b. And all I'm going to do is plug in that slope. So we have y is equal to negative 4 over 3 x plus, and earlier on we decided that the y-intercept is at 30. So then it's going to be plus 30. So our equation for the walk home from the bus stop is y is equal to negative 4 over 3x plus 30. And then question 4 is asking, how does the equation you wrote to represent Jack and Jill's walk home from the bus stop compared to the equation that represents their walk to the bus stop? Okay, so as a reminder, the equation for walking to the bus stop is y is equal to 4 over 3x. The equation walking home from the bus stop is y is equal to negative 4 over 3x plus 30. So the first thing that I noticed is that, as we talked about earlier, the slope has the same number, right? 4 over 3, but for walking to the bus stop, it's positive, and walking home from the bus stop is negative. So I'm going to go ahead and say that both equations have a slope of 4 over 3, but for the walk home, the slope is negative. And next, because walking to the bus stop was a proportional relationship, it went through the origin, right? But walking home from the bus stop had a b or a y-intercept. So then I'm going to write walking to the bus stop was a proportional relationship. And walking from the bus stop, walking home from the bus stop, was non-proportional. So it had a y-intercept. And again, the y-intercept was that 30. We're going to skip over question 5a and b and go straight into this we do. Okay, so it says the equation y is equal to 2x plus 5 gives the total height y of a plant in an experiment that was 5 centimeters tall at the beginning of the experiment and grew 2 centimeters each day. Represent this linear relationship on a graph. So it already gives us the equation y is equal to 2x. Sometimes these problems are just going to give us the word problem. We have to start writing an equation, but this problem made our lives easier by giving us the equation. Okay, so we have x is equal to 0, 5, 10. So we have to plug in all those x values into the equation. So we're multiplying 2 times 0 and then adding 5 to that. So 2 times 0 is 0. 0 plus 5 is 5. So that means that when x is 0, y is 5. Another way that we learned how to do this is on Desmo. So I'm going to go ahead and remind us how to do that. We can just type in the equation, which is y is equal to 2x plus the 5. And then from here, I want to make a table from this equation. So I'm going to go to settings, the gear, and then I'm going to click on table. So I have to change some of the values because our x values didn't include -2, -1, 1, or 2. So I'm going to go ahead and delete this and change it to 0 so that we can confirm that y is 5. Change this to 5, change this to 10. So now we can see that when x is 5, y is 15. When x is 10, y is 25. Okay, so now I have to decide what my scale is going to be along the x-axis as well as the y-axis. So if I count from the origin all the way to the right, where it's labeled x, I can see that I have 10 boxes. And thankfully, it goes from 0 to 10. So that means that if I have 10 boxes, I need to go to 10. 10 divided by 10 is 1. So that means that each box can represent 1. So instead of labeling each one 0, 1, 2, 3, 4, 5, 6, I'm just going to label it 0, 5, and 10. Okay, then next, I have to figure out my scale for the y-axis. So I can see that my y's range from 5 to 25. That's actually called the domain. And so I only have 10 boxes, the same 10 boxes, right? So I can't count by ones anymore. So I am going to be counting by 2.5, just like the graph earlier on. So every 2 boxes is 5. So we have 5, 10, 15, 20, 25. If I wanted to, I could count each box by 5s, but then my graph would be a little bit squished. It would look a little bit like the points would look a little closer together. Okay, so I have 0, 5. So that first point is right here. I start at the origin, go up 5. Then we have 5, 15. So I start at the origin, go to the right until I see the 5, go up until I see 15. And lastly, we have 10, 25. So start at the origin, go to the right until I hit the 10, go up until I hit the 25. So then draw a line through the points, and this is my graph. So again, as long as you correctly label the x and the y-axis, your graph can look a little bit different. Make sure that your scale is consistent for the x and the y-axis. So you can't just go from this first number being labeled 5, this second number, instead of being labeled 10, being labeled 20. Okay, so then we have a we do. So in this case, we're actually given a graph, and we have to find the slope, write the equation. Okay, so this problem is saying a company sells bottles of vitamin capsules. The graph shows a linear relationship between the cost per capsules in cents and the number of bottles ordered. We have to figure out what is the slope of the line that models the situation, and then we have to find the equation in the form of y equals mx plus b. So just looking at the graph, if we had to draw like a line, we can see that it's non-proportional, right? Which is why we're writing a line in y equals mx plus b form. Okay, so we're gonna start by making a table. And we have to have at least 2 points for non-proportional relationships. So my first point I'm gonna choose is 2, 6c. And you don't have to choose the same points as me, but as long as you do the math correctly, then you should be able to get the same answer. And my second point is gonna be this 4, 50. So I'm going to use the slope formula that we talked about earlier that we previewed. M is equal to y2 minus y1 over x2 minus x1. And before I start solving, like plugging in numbers and subtracting and dividing, I'm going to go ahead and label the points on here. I'm going to say that 2 is x1, 60 is y1. The 4 is x2, the 50 is y2. So then if I do y2 minus y1, that is 50 minus 60. So big mistake that I see students make is they subtract the y minus the x. So they would have done 50 minus 4. So remember, the equation is y2 minus y1. So you need to subtract the 2 y values. Next, we have x2 minus x1. So I'm subtracting the 4 minus the 2. So of course, we have 50 minus 60, which is negative 10. 4 minus 2, which is positive 2. And lastly, we have negative 10 divided by positive 2, which is negative 5. So that means that the slope is negative 5. So from here, I'm going to start to write an equation. So the equation that I'm going to start to write is going to have that -5. So it's going to be y is equal to -5x. I don't know what my b is yet, so I'm going to go ahead and have to solve for that, right? So we have y is equal to -5x plus b. So to do that, I have to choose one of my points. So I'm going to choose my first point right here, and I'm going to plug in the numbers. So we have our y value is 60. So we have 60 is equal to -5 times what is our x value? It's 2. And then we have to add b. So next we have 60 is equal to -5 times +2 is -10 plus b. And then from here, we want to move the -10. So the opposite of -10 is +10. So we're going to add 10 on both sides. -10 plus 10 is a 0 pair. It makes 0. So we have b is equal to, and then 60 plus 10 is 70. So that means our y-intercept is 70. Our slope was -5. So to combine that into our equation, we have y is equal to -5x plus 70. And then our last problem here is another graph, but it has a shape, right? It has a triangle. So it says triangle PSV is shown on the coordinate grid. The coordinates of each vertex of the triangle are integers. Find the slope of the 3 sides. So the way that I'm going to remind us how to do this is making a table. So we have x comma y. Okay, so then I have to write my point for P and then my point for S. So for P, we have 1 comma 6. And then for S, we have 5 comma 2. So I'm going to remind us that to make a table on Desmos, I have to go to plus, table, and then I'm going to go ahead and plug in the 2 points. So 1, 6, 5, 2. And then to find my slope, I have to type in this equation. It is the y1 tilde mx1 plus b. And then from here, I can see that my m is -1, my b is 7, right? So that means that my slope is going to be -1. Okay, for this next problem, I'm going to make a table. So S, we know was 5 comma 2. V, we know is 1 comma 2. So I'm just going to change the numbers in the table. I don't need to delete that equation, y1 tilde mx1 plus b. So we have 5 comma 2. So I'm just going to change this one to be 1 comma 2. So that's 0. Our m is 0. So something to remember is that anytime you have a horizontal line, so line going from left to right, your slope is going to be 0. And then the last one is for VP. So I'm going to make my table, my last table. So V again is 1 comma 2. P is 1 comma 6. So for this one, I want to show us how to do it on Desmos, but Desmos is wrong for this one. So we have that 1 comma 2. Then I have to change this to 1 comma 6. So you can see that Desmos tells us that my slope is 4. So you can see that on this graph on Desmos, you can see that our rise was 4, right? But then our run was 0. So let's say our rise was 4, our change in y was 4 over a change in x, but our run is 0. And you can't divide a number by 0. So anytime you have a vertical line, even if you try to put the number into Desmos, it'll give you a number, but it'll just give you the rise. You have to remember that if you have a vertical line, the slope is going to be 0. And just to make sure that we can do this problem, I know we just made tables and found the equation, but just to check this, we'll go ahead and plug in these numbers. So we had 260 and then 450. So again, we have that y1 tilde mx1 plus b. You can see that our m, our slope was -5, our b is 70. Okay, so then the rest of the lesson is independent practice as well as our DOL. Thank you so much for following along in today's lesson.